So let's begin part two or video two of part one. So this video is going to talk about atmosphere stuff and a little bit of water stuff, and then the soil and like soil resources is going to be next video. So let's start with the atmosphere here. This is something that we haven't seen since, oh wow, semester one. And we know that our atmosphere has layers to it, right? The bottommost layer is the troposphere, and then above the troposphere is the stratosphere, then the mesosphere, and then finally the thermosphere. There is one more level called the exosphere. This is technically the small layer just before space. The ISS hangs out there, but that's usually not included in most atmosphere models. But what you do need to know is this kind of like this temperature curve that occurs here with the temperature fluctuations as you go up in elevation. So in the troposphere, as you go up in elevation, the temperature decreases. And then it kind of changes right after the tropopause. In the stratosphere, the higher you go, the temperature gets warmer. And then the mesosphere, the higher you go, the temperature gets cooler. So that's the thing. You might want to know what happens at each layer. The majority of everything that matters to us happens in the troposphere. That's where the greenhouse gas effect occurs. That's where clouds occur. That's where weather occurs. That's where planes fly. Virtually everything we care about occurs at the troposphere. What's important about the stratosphere is the stratosphere has the ozone layer, right? And the ozone layer protects us from UV, right? So protects us from UV light that can otherwise cause burns, which can lead to cancer and all that stuff. But that's, I'd say, the two most important layers of the atmosphere for environmental science. The troposphere, that's where weather occurs, and virtually everything that matters to us happens in the atmosphere. And then you get the stratosphere, which of course has the ozone layer. Let's move on to here. This is something that we didn't spend too much time on in class, but it wasn't a Bozeman video, and that's the idea of a rain shadow. So a rain shadow is an area where you're not going to get rain because the wind, the thing that carries the air and the moisture, is blocked by a mountain. So this here is a mountain, and let's say the wind is blowing this way. So the wind is blowing towards the mountain. The air will be forced up the mountain. Now, what happens as you go higher and higher in the stratosphere? Where it gets colder, so the air starts to cool down, which means it starts to lose some of its moisture. So you're going to get a lot of rain on the side of the mountain where the wind is blowing from. But by the time the air makes its way over the mountain, it will already be dry. So this idea that on the opposite side of the mountain, there's not going to be a lot of rain because the mountain is blocking the wind. You can even see that from space. So here is a picture of the Sierra Nevada mountain range. So these are sort of on the eastern edge of California here. So these are the Sierra Nevada mountains, and you can even see it from a satellite view where over here on the side of the mountain, there's greenery and green space, but over the mountain, this is like dry. And it's dry because the mountains have effectively blocked the moisture from coming into that area. So this is now to discuss the Coriolis effect. So the Coriolis effect is the deflection of wind as a result of the Earth's rotation. So in the northern hemisphere, things tend to get deflected to the right. Things in the southern hemisphere kind of tend to get deflected over to the left. Now, this is, of course, relative to motion. So if you're going north in the northern hemisphere, so following this arrow, right, things get deflected to the right. If you're going south, things get deflected towards the left, relative to this diagram. So this is just kind of something if you don't intuitively automatically know or can think about the rotation of the Earth, it's just something you kind of have to memorize. If you're moving away from the equator in the northern hemisphere, things get deflected to the right. If you're moving away from the equator in the southern hemisphere, things tend to get deflected to the left. How does solar intensity and atmospheric convection currents influence the location of major biomes? Well, wherever you're going to get an updraft, you're going to have a wet climate, so kind of like how tropical rainforests are along the equator. and why deserts are in areas where there's a downdraft. And then here in the upper regions, where you get to the temperate regions, the updraft is a little bit weaker. So you get rain, but it's nothing like the torrential downpours that you'd get in a rainforest. Moving on. Describe how ocean currents, temperature, and gas concentrations are directly related to those of the atmosphere. So this is asking, how is the ocean related to the atmosphere? And I kind of wrote it out for you here. So the surface ocean currents, so the water that moves along the surface of the ocean, that's controlled by the wind, right? So as the wind is blowing, the top layer of water is pulled along with it. So the movement of the atmosphere is what ends up creating these top patterns of water circulation in the ocean. But there's actually a lot more involved there. So if you think about water having a higher heat capacity, so this is something you may have learned in chemistry, the heat capacity of different substances. Water has a higher heat capacity than air, which means it does a better job storing heat for longer periods of time. And because of this, air temperatures tend to be a little bit warmer near bodies of water, only because that ocean is storing heat and then slowly releasing it throughout the day. And then the important one, the true relationship between the ocean and the atmosphere is that gases dissolve in water. So gases can dissolve in water like dissolved oxygen, dissolved carbon dioxide, but that carbon dioxide can later have a reaction with the water and form carbonic acid. So the higher the concentration of gases in the atmosphere, right, if those gases are in the atmosphere, they will dissolve directly into a body of water. And the more of those gases there are in the atmosphere, the more of those gases you'd expect to find dissolved in the ocean. So especially in the case of carbon dioxide, something like carbon dioxide, which is found in increasing concentrations of the atmosphere, is dissolving into the ocean at a faster rate, which is causing ocean acidification, which is causing brain fart, which is causing coral bleaching, right, and the loss of major ecosystems. So let's move on to another interaction between the atmosphere and the ocean, and that's ENSO, or the El Nino Southern Oscillation, the El Nino Southern Oscillation. And it's a phenomena that occurs in the Pacific Ocean. So here we have a diagram of the Pacific Ocean, and we're looking at what an El Nino event is. Let's start with normal conditions. So normally in the Pacific Ocean, you have surface winds, right? So winds closer to the bottom that are blowing away from the Americas and towards the Asian side of the Pacific Ocean. And what this does is it causes a buildup of warm water on the Asian side of the Pacific Ocean. And because this water is being moved away, it allows for upwelling of cooler water near the South American side. So this is where upwelling occurs. And these are the normal conditions. It creates wetter, rainier, warmer conditions on the Asian side of the Pacific Ocean, and it creates slightly cooler, drier conditions on the American side of the Pacific Ocean. During an El Nino condition, or during a strong El Nino condition, the winds shift direction. So the wind now blows towards the American side of the Pacific Ocean. And that's reducing the amount of upwelling. And it's causing there to be more rain on the American side of the Pacific Ocean. There is, of course, a whole bunch of side effects related to that, economic effects. I think those are things that should be easy for you to review on your own. Let's talk about global water resource use. So here, about only 2% of the world's water is fresh water. 98% of all the water on the planet is salt water. And of that fresh water, the majority of it is ice. The majority of it is locked away in the glaciers and the ice sheets. And the ones that are accessible, so the accessible water is mostly groundwater. And then just about 1% of all of our water resources are freshwater resources the way we think about it, lakes, rivers. So that's only about 1% of all the water that's available to us. And there's a couple of things that we might want to consider about the water a little bit. So the first one I want to talk to you about is one we didn't spend too much time in class on, is evapotranspiration. Evapotranspiration is all the water moving into the atmosphere. So evaporation means water evaporating from the ground, evaporating from bodies of water, and transpiration, that's plants losing water to the atmosphere as they do photosynthesis and they take water from their roots and up through their leaves. It's trees losing water, and that's transpiration. And that's part of the global water cycle, right? Evaporation from rivers and transpiration from plants is what gets water into the atmosphere. And transpiration is a huge flux. And by huge, I mean the largest river in the world. If you want to consider a definition of a river as a flow of water, the largest river is actually in the Amazon, but it's not the Amazon River, it's in the sky. The amount of water that transpires from the trees in a rainforest creates the largest flow of water on Earth, and it happens to be in the atmosphere, right? All these clouds, that's just condensed water in the atmosphere. So transpiration is a huge part, a massive flux in the hydrological cycle. Let's look at watersheds. So a watershed is all the movement of water in an area. So it's the geography of the land that causes a flow of water. And most watersheds will begin at mountains, so where there is snowpack and rain happening at mountains, and it'll include everything all the way down to where that water empties, usually into an ocean. And the reason why we like to think about watersheds is because the placement of things is very important to water quality. So you don't want to have a hazardous disposal area in a place where that water can infiltrate the watershed. You don't want to have farms too close to a watershed because you might get runoff and things. So this is why thinking about a watershed is important. Let's move on to a couple of locations and explain the groundwater and surface water issues occurring there. So the Colorado River Basin is literally, well, the basin of the Colorado River, and it kind of looks like this. In 1999, it was obviously fuller of water. In 2013, it's got even less, and it pretty much looks the same today. It is the major source of water for Colorado, Nevada, Arizona, and we've been taking too much water out of that river. It's also the river that the Hoover Dam is on. So you end up getting a lot of water use, and it has depleted the water resources in the Colorado Basin. So we're depleting those resources. Let's take a look at the Ogallala Aquifer. So the Ogallala Aquifer is one of the largest aquifers in the world. It happens to be in the United States. And it's along the Great Plains states. So if you're looking here at Nebraska, Kansas, Oklahoma, Texas, all these states have a very important industry there, and that's farming. So this Ogallala Aquifer is pretty much what waters the entire farmland and grassland of the central United States. And one of the issues of the Ogallala Aquifer is that we are taking water out of it faster than it is percolating back in. The last water issue I want to talk about is the Aral Sea. The Aral Sea is right next to Kazakhstan, so it's on the western side of Kazakhstan, so it's in the Middle East. And it's also been depleted because that area of the world has a cotton farming industry. Cotton relies on a lot of water, and it's the Middle East. It's not very water efficient right now. So the Aral Sea has been depleted for agriculture in this part of the world. So now that we're back on this side of the screen, let's take a look at why fresh water is considered an ecosystem service. So there's a couple of different ecosystem services, right? There is provisioning, regulating, all those other ones. Water provides habitat. Water allows for recreation. We get to fish out of water, so it can provide us food. So as an ecosystem service, fresh water is very important as an economic service. We use it for transportation, right? So if you think about major shipping routes that occur on oceans, barges on rivers, we use water for transportation. We use it for recreation. So if you've ever gone jet skiing or maybe you've gone kayaking or something like that, right? Those are economic services because it's something you pay for. It's something you get to do. Water as a global security issue is very rarely talked about, but is becoming a bigger issue. If you go back to this diagram of how little amount of the water is fresh water, and our access to fresh water is becoming more and more scarce, right? As the Colorado River Basin dries up, as we're irresponsibly using aquifers and groundwater, and drying up entire bodies of water. Access to water may very well become a global security issue very soon, as countries or even states with water start to do some like power plays with countries and states who don't. So great, that's something to look forward to in the future. Water wars. Natural capital is a natural resource, right? Freshwater is a natural resource because we use it for transportation, right? We use it for food. We use it for transportation. So a lot of these have very common explanations to them. Let's take a look at ways to conserve water. And this is the last thing we're going to talk about, water is conservation strategies. So one of the things we can do to conserve water in agriculture is to use more responsible irrigation methods. So we learned about a couple. We learned that drip irrigation is the most efficient and the most water responsible way of irrigation. So we can switch to drip irrigation for the majority of our crops. Municipal means city use. So the biggest issue right now in freshwater conservation is actually pipes. So in Chicago, a lot of our water pipes are leaking. They're leaking underground. It's the pipes that are one of the biggest issues and one of the biggest losses of water in municipal use. But we can do stuff like, buy low flow faucets and low flow shower heads that use less water. These are things that you can buy that have water responsibility kind of built into them. As far as energy production, we can conserve water with electrical production, not so much by using less water, but being careful with where we build it, right? If we build a dam, are we keeping track of flooding upstream? Are we building it in such a way that fish can still migrate up and down rivers? If we're building tidal power, are we building it in a way that's responsible, that isn't destroying coastal ecosystems? So how we build it and where we build dams and different forms of hydroelectric power would be considered conserving water resources, even though we're not directly actually taking water out of somewhere. And then there's industrial water use. And really, the solutions there are all legal, right? How much pollution are we releasing into bodies of water? Fracking contaminating groundwater, oil spills contaminating ocean water, these industrial factories that may be dumping hazardous waste into rivers, which are getting into lakes. Are we keeping track of and are we enforcing pollution regulation? So there are just a couple of the things that we can do to conserve our water resources. Next video, we're going to get into soil and soil dynamics. So that's kind of the next video we're going to touch on here. Maybe what I need is intro music.
Science with Mr. W. Science with Mr. W. Science with Mr. W. Science with me.
I promise to never do that again.